All right, we're back at it. Um, we're looking at exponential applications, which are technically going to be word problems. These are probably some of the easier word problems you'll ever do. You're just kind of following a blueprint. You don't need to make your own equation. We have formulas for you, and you're just going to plug it in your calculator. And that's about it. So, moving forward, to start, we'll start with some basic formulas that you have probably seen before, most likely in Algebra 1. That's the growth and decay formulas. So these are basic exponential growth formulas or decay. So notice the formulas are the same. A equals P times 1 plus R all to the T power. Decay is the same formula, it's just subtraction instead. That's it. So looking at what those variables represent, A represents the final amount. P technically represents the principal. That's what the P technically stands for. All it is the starting amount, the amount you started with. R is rate, as it is pretty much in every word problem you'll look at for the most part, algebraically at least. And T is time. Same thing, that was pretty typical there. So you're going to use both these formulas for each of the problems. It just depends on what keywords you're looking for, and I'll kind of point those out as we go. As always, I have more work than I probably need to show. I'll tell you on the next slide what I need to see from you guys. So I need to see 3 things in every problem when you give them to me. So there's not much work you're going to show. If you want to show more, go for it, but it's pretty much all calculator work. An actual calculator works the best versus a phone, so if you have that handy, that'd be helpful. Doesn't need to necessarily be a graphing calculator, just needs to be a calculator. I think that would be the best. But I need to see the information pulled out, need it to see it plugged in, then I need to see the answer. So those are the 3 things, and I'll show you what that looks like. I'll box them in on each problem, so all the extra work that I do off to the side is only for your benefit note-wise. It's not necessarily something I need to see. So, examples with just these 2 formulas. Alright, first one. The number of bacteria present in a colony is 180 at 12 noon. And the bacteria grows at a rate of 22% per hour. How many will be present at 8 p.m.? So, a couple things. Big thing here. It grows. So you're using the plus formula. You're using the addition one, the growth formula, just based on that keyword right there. I have some variables given to you in color-coded, and they'll be color-coded the same way throughout our notes. So we started with 180 bacteria in what we have. We started with that. We know our rate's 22%. I'll talk about that here in a second. And our time is 8. We don't know what our final amount is. That's what we're asked to find. This is my little bit of work if you guys want to show anything. This is my info pulled out. This is what I need to see that's boxed in. 22%. Percents are technically not numbers. They're a representation of what a number is or what that value represents. So to convert percents to a decimal. So as always, you move the decimal place 2 places to the left. So I showed that here. The value you end up using is a 0.22. Our time is 8 hours from 12 noon to 8 p.m. That's 8 hours. That's how I got 8. Then I literally plug it in. Show it to me plugged in. That's it. After that, you literally type it in your calculator, and we'll just round it 2 decimal places pretty much on everything we do. Alright, so everything that's boxed in is what I need to see. Anything outside the boxes is up to you if you want to show anything else. Alright, I want to see what's in the boxes. That's it. So, moving on. We have more given to us here. A house purchase for $200,026 has lost 4% of its value each year for the past 5 years. What is it worth now? We are losing value. Alright? So that means we look at the subtraction portion of the problem. We started with a house value of 226,000. Our percent rate is 0.04. It's over 5 years. I want to know what the value is after 5 years. So again, boxed in is what I need to see. You just take that information, you plug it in. That's it. Plug in the calculator, you get an answer. All right. Next. Just an extra example, just another keyword here. I'm not going to walk through this one. You can see it. It's pretty self-explanatory. This is what I need to see. Everything, there's no extra work involved. Appreciated means you're going to add. Depreciated means you would subtract if you see that at all. So appreciated, if you appreciate something, that's a good thing. So you're just going to add to it. Next, we got another formula. Everything else remains the same. If you notice, the formula looks the same. Just I'm adding the n value into it. We have a equals p times 1 plus r over n, all to the nt power. Now, everything a, p, r, and t, same thing. N is the number of times compounded. So it'll say in the problem that something got compounded annually, semi-annually, quarterly, monthly, weekly, daily. These are those values. So if I say something was compounded quarterly, that means that value is 4 times a year. All right, let's look at some examples. Again, everything's color-coded. Your P is 2,000. Your percent, your interest rate, your rate is green. Your compound, your N value is blue now. And your time is staying orange. So I just pull the information out, show the percent work again for you. I think I showed that for you on a couple more problems as well. Literally just plug in the information. Literally just plug it in. Those two, you get 2 out of 3 points just by copying information down. That's it. You have the formulas in front of you, use them, take it from there. All right. Plug in your calculator, that's your answer. In this case, you're definitely always, anytime we're talking about money, you are rounding to 2 decimal places. That's a guarantee. All right, so again, boxed in is what I need to see. Anything beyond that is up to you. All right. Another one. There's not much, anything different to tell you here. So I'll just leave that up there for you, just a different percent to deal with. Next one, we switch it up a little bit more though. Not a ton. I'm asking how much more would 2,500 make at 8.25% interest if it were compounded annually versus weekly over 10 years. Now, this one, and on the worksheet, I'm going to give you 2 setups here. I need to plug this into 2 formulas. I have 2 different n values. I have one that's compounded annually, so 1 time, one that's compounded weekly, so 52 times. Everything else remains the same. You notice the copy of the information down. All right, I didn't mean to move all that. Now, info pulled out, same thing. Info plugged in, I need to be seeing 2 bits of information plugged in. One for annually, one for weekly. So I should see 2 different formulas. They'll be very similar, but I need to see 2 formulas. That means I get 2 answers here. Now, this is not the final answer. These 2 separate. I asked how much more would one make than the other. So all I do is subtract, and my answer is here. But I need to see all the stuff that's boxed in, so I need to see a little bit more on a comparison problem. All right, just keep that in mind. Last switch up here. I want to have $55,000 in the end in one of my retirement accounts after 35 years of working. How much will you have to deposit into an account that pays 4.5% interest compounded monthly? So I switch the A and the P. I'm looking for I know what I want to end up with. I know my final amount. I don't know what I want to start with though. So I have my information different. I have A, I don't have P. All right, keep that in mind. Now, I kind of show a little bit of extra work here just to kind of walk you through that process and what you're doing. But I still only need to see 3 things. So again, this work is not necessarily stuff I need to see. Deal with the parentheses first. Parentheses and exponent first. Do it all at once. You get this number here. Alright, that's the whole number that came out of my calculator. I divide both sides by that number. Then I get my answer of 32 grand. So I would have to deposit $32,000 in order to end up with 55,000. Alright, so just keep that in mind. There's another example here. I'm just asking for what principal. It's the same thing. Principal, that's your p-value. I don't know that. I know my final amount though. Alright, so homework this week, you got I think 8 word problems. You show me the information pulled out, plugged in, and the answer. That's it. Now, me showing you answers this week are going to be a little bit different. I'm going to give you maybe something that the answer starts with, because if I give you the hard part of it, that's not going to really help us out. You guys can just plug things in, no problem. So I'm going to switch up how I give you the answers this week, or just something to lead you in the right direction at least. As always, if you guys have questions, hit me up. And that's about it. Have a good week, guys.